Okay guys, so we're gonna do our first example of how to solve a system of differential equations. So first we're gonna start with a review of how to find eigenvalues and eigenfactors. How to find eigenvalues and eigenfactors, eigenvalues and eigenvectors of a matrix. Okay, so why do we need to do that? Why do we need to use these eigenvalues and eigenvectors? Okay, so in linear algebra you probably calculate this, but you not sure. Hopefully they explain to you what it is useful, right? If not, here is the theorem. Why do we want to review this? Okay, why is that important? So this is why. So theorem. Let's say let me just do a 2 by 2 matrix, right? So let lambda 1 and lambda 2 be two distinct real eigenvalues of the coefficient matrix A of the homogeneous system and let's write x prime equals ax. Okay, and let k1 and k2 be the corresponding eigenvectors. Be the corresponding eigenvectors. Then the general solution of the I'll call it 2 star, right? So this is the same 2 star, I think. The solution of 2 star is given by the solution of 2 star on the interval. This is really good. The solution the solution of 2 star on the interval minus infinity to infinity is given by x equals c1 k1 e to the lambda 1t plus c2 k2 e to the lambda 2t. So here lambda 1 and lambda 2 are the eigenvalues and k1 and k2 are the eigenvectors. So you see this looks very similar to the homogeneous second order differential equation, but the difference is that in that case the lambda 1 and lambda 2 were the solutions of the characteristic polynomial, and the k1 and we didn't have these eigenvectors, right? Okay, so that's the theorem, and that's what we're gonna do. So that's what this is. So that's the application of the eigenvalues and eigenvectors to system of differential equations. Okay, so let's see. Let's start with an example. This is review. So let's consider the matrix 2, 3, 2, 1, and let's find the eigenvalues. Let's find its eigenvalues and eigenvectors. Okay, so for this, so you already took linear algebra. So the way you should do this is we need to find the determinant of A minus lambda I. Okay, so remember that an eigenvalue and eigenvector, we're looking for solutions of the system. Let me do a little here closer review. So remember that AB lambda B. Okay, so an eigenvector will be a real value or complex value such that AB equals lambda B. So what does it mean this? So matrices, what they usually do, so you have a vector, this is B. A matrix, what it usually do is rotate the vector, usually give a rotation to the vector and make it longer or shorter. So you apply usually you apply to a vector, a matrix, your new vector is gonna be like this. Okay. So this is your vector, and you apply A to the vector. So usually you rotate it and make it longer or shorter. Okay. So what is this saying is really interesting. But what it's saying is that so you know what it's saying or not? You think about it. So what this is saying? What is this is saying? So stop the video and think. What is this telling me? So what it's telling us is that if you have the vector B and you apply the matrix to that vector B, so the new vector is going to be longer or the other direction, or can be shorter. But basically they are keeping in the same line. Okay, so they are linearly dependent. Okay, so that's the whole thing of these eigenvalues, eigenvectors. Basically, you have an eigenvector when the vector is not rotated. Okay, it's basically staying in the same line, and it's basically you are making it longer or shorter. Okay. So yeah, so you need to solve this equation, right? But then, so how would you solve that equation? Let's suppose you are on the real numbers. How would you solve an equation like that in the real numbers? So you have phi x equals lambda x. So is that right? So you need to find lambda. You need to find, well. So let's put it more like so is that a good example? Phi x equals lambda x. Yeah, okay, well, yeah, that I think is a good example. So yeah, so let's suppose, yeah, of course you can tell that is lambda equals, it's gonna be lambda equals something, right? But because, it doesn't make too much sense in this case because this is not a matrix. But how will we solve this system? Let's say we are not gonna solve it trivially, so we could do phi minus lambda x equals to 0, right? So you wanna know when this one can be invertible, right? So if you have two options here, right? X is 0 or phi minus lambda is 0. But usually you don't want x equals 0 in these cases. You don't be the vector 0. Probably you don't want it to be 0, right? So you have lambda equals 5, right? But in here involved inside of this, basically uh, there is some inversion thing here, okay? How when this you can invert this, okay? So here that's if you have a matrix, right? So let's say you have ax equals lambda x, right? So you try to do the same steps. So you do ax minus lambda x, and you want to factor it gives you 0, right? So you try to factor the x, right? So you got a minus lambda x equals to 0, but then you have a problem, right? Because this is a matrix, and this lambda is what? This lambda is a number. So you need to multiply times the identity. And that will make sense, because a minus lambda I times x will give you the same over here. And you don't trust me, let's do it with your matrices. This is review, so I'm not gonna do it. So then you need to solve this system. When can you solve this system? So you see how important here was to find the solution that gives you 0, right? You want to know when the determinant is 0. So here's something like that. That's what you want to know, when the determinant is 0. Okay, so all this to say that that's how you find eigenvectors and eigenvalues. Well, for at least eigenvalues for now. So the determinant, so you find your determinant. So it's what? 2 minus lambda. 3 doesn't have, because this is diagonal, right? So I'm subtracting 2a. I'm subtracting 2a lambda 0 0, because that's the identity. So I get 2, and then I get 1 minus lambda. So I find the determinant, so I get 2 minus lambda times 1 minus lambda minus 6. So once again, I got quadratic formula, right? I'm getting 2 minus 2 lambda minus lambda plus lambda squared. So that gives us lambda squared minus 3 lambda plus 2. Plus 2 minus 6. So I forgot the 6, okay, minus 6. So I get lambda squared minus 3 lambda minus 4. Okay, so I make this equals to 0. That's how they find your eigenvalues. And then I can factor this like lambda plus 1, lambda minus 4. So from here I get lambda equals minus 1, lambda equals 4, right? Okay, so I found my eigen values. So let me raise all this over here. So I have my eigenvalues here. So I'm gonna need, now I need to find, these are my eigenvalues. So I'm gonna need to find my eigenvectors. So So let's find the eigenvector corresponding to lambda equals -1. So if you have lambda equals -1, so what do? So remember, you need to solve the system AB equals lambda B, right? But you know what is A, right? So A is 2, 3, 2, 1. 2, 3, 2, 1. Let's say times B1, B2 equals lambda, that is minus B1, B2, right? So when you multiply this, you get 2B1 plus 3B2 equals minus B1, and you get 2B1 plus B2 equals minus B2. 2B1 plus B2 minus B1, 2B1 plus B2, yeah. So I get 3, so from here, I get 3B1 plus 3B2, right? Equals to 0. And I get 2B1 plus 2B2. Okay. Yeah. So now we need to solve these guys, right? But you see, this is gonna happen very often. What do you see here? You see that if you divide by 3 and this one you divide by 2, you're gonna get the same equation. You will get B1 plus B2 equals to 0, and then B1 plus B2 equals to 0. So you really have one equation. So you what really have is B1 equals minus B2. So remember, you just need one. Once you find one eigenvector, you will find infinite, because all of them are in the same line. So they will skip, they will not be rotated. Okay. So you just need one eigenvector. So you can, let's say I choose B equals 1. If I choose B equals 1, then well, let's choose B2. Well, okay, let's do it like that. B1 equals 1, so I get 1 equals minus B2. So B2 equals minus 1. So this is my eigenvector for minus 1. So let's say you don't believe me. Okay, so fine. So let's do it. So we're gonna check it. So 2, 3, 2, 1 times 1 minus 1. So I'll give you 2 times 1 is 2 plus minus 3. And then 2 times 1 is 2 minus 1, right? 2 minus 3, 2 minus 1. So you get minus 1 and 1. So what is the eigenvalue? The eigenvalue is minus 1. So remember, what I want to check is AB equals lambda B. So AB give me minus 1, 1. So lambda B is minus 1 times my eigenvector. My eigenvector is 1 minus 1. So this is the part, and then I will get minus 1, 1. There you go. Check. So that's correct. So that's my eigenvalue. So 1 minus 1 is my answer, my eigenvalue. Okay, so let's say if lambda equals minus 1, my eigenvector is 1 minus 1.